While it says that the broadcast has started, I'm assuming the broadcast doesn't start for another 8 minutes.
Hi, yeah, this is Corey from MassCEC. Just getting it started in case any attendees hop on early. But yeah, we'll see how many people are here around 11 and then potentially give it a couple more minutes. And then Gabby, who's also on the line from MassCEC, will go through some of our intro slides, just introducing MassCEC and what this presentation series is. And then we'll have you get started.
There is a very first slide you may have seen, which is a cartoon.
Yeah.
That's a gap. That's a kind of a gap. Gives them requires a couple seconds for them to read. So if you're going to be introducing me, can you start with that particular slide, and then I will go into the main lead slide after I have a couple things to say during the cartoon, and then I will go into my second slide, which is actually normally the first slide.
Yeah, I'll leave it
Does
on that
sense?
side when Gabby gives the intro.
By the way, how do am I telling you slide? Because I believe I have no control.
Yeah, so we'll control the slides and then just let me know and I'll advance them for you.
Got it. And what's your name again?
Corey.
Corey. Hi, Corey. With a C?
Sorry?
With a C?
Oh, with a K. K-O-R-I.
K-O-R-I.
Yep.
I was trying to figure out with, was it Jude? Is that his name? How do you pronounce it?
Yeah. Yep.
How to do a live demo, but I think that we'll just use the video. I couldn't figure out how we get a second camera going.
Yeah. It's hard.
We do this quite a bit when I'm doing actual product demos. They have the screen. I share the screen while also having my phone shooting live demos, showing me putting the sensor on. But I think the video that we've got pretty much covers everything. Corey, is at the end, would my laptop video camera, will that also be on if I ask for it to be on?
I'm not sure.
Okay.
Yeah, it looks like you have the option to share your webcam.
Oh.
All right, I think we're good to get started. Gabby, if you want to take it away with the introductions.
All right, great. So, hi all, thank you for joining us virtually for a MassCEC CleanTech Spotlight webinar series presentation. To briefly cover some housekeeping items, all attendees are currently in listen-only mode. We'll start by quickly introducing the webinar series, then we'll introduce the guest speaker for today's webinar and let them present on their company and technology. Following the presentation, there will be roughly 15 minutes reserved for questions from the audience. If you have a question, please use the question submission feature and type it in as the presentation is happening, and we can ask them on your behalf. Now, to give a short introduction to MassCEC's work, MassCEC's Tech Dev program suite consists of 3 programs: Catalyst, Amplify, and Innovate. Each of the programs target providing support to clean tech startups and researchers at different points in their technical and commercial development, from prototyping to demonstration with industrial partners. Today's presentation is from a Catalyst grantee. Alex will present on Vata Verks, a company that develops non-invasive real-time data acquisition solutions for building water and natural gas. This technology eliminates the need for third-party coordination, building disruption, and project schedules. Thank you again for joining us, and please enjoy the presentation.
Hello, can everyone hear me?
Yep.
Okay, good. My name is Alex Scheimitz. I'm CEO of Vata Verks. And happy belated Earth Day to everyone, and a big thank you to MassCEC. I want to be sure I get that out up front because MassCEC has supported us in many ways over the years, to start with as a Catalyst winner and also through their most fantastic internship program. So I put this cartoon up for a reason. Hopefully you've all had a chance to read it. It's about drastic measures, and as we turn the corner on another Earth Day, I think we think about what those drastic measures are on saving water or saving energy. And in many respects, in many parts of it, these things have been solved in electricity, for example. But in plumbed utilities, water and natural gas, there is the question of how to take drastic measures, which drastic measures to take, which ones have the most impact with the least disruption, and hopefully, no chalk lines in the kitchen. That question was still open when we started Vata Verks. Next slide. Thank you. Vata Verks was started to solve the problem of data acquisition for plumbed utilities. And actually, because from the name, Vata Verks, we actually started just for water, to solve the problem of getting usage information back to the users so that they could make decisions on use, efficiency, leak detection, anomalies. There are a myriad of reasons that you would want this data. And most importantly, the kinds of investments you'd want to make to reduce usage. All of those things require information which was not available in the single data point that commercial and residential customers get in their monthly bill. Let me tell you a little bit about my background. My background is in the development of major appliances. I come from the dark side, making glistening stainless steel cooking appliances. I spend way too much time in kitchen and bath shows looking at inefficient, beautiful appliances that are way too expensive to do what a standard appliance could do, but they look much better doing it than yours. At the same time that I was developing major appliances, I also started a information website called Appliance Advisor. That first cartoon was from there, that reported and analyzed appliances for their efficiency and held manufacturers and Energy Star to task for fulfilling their obligations in an open, non-corrupt way. There is a lot of corruption going on. It's not illegal corruption, a lot of corruption going on in the testing and certification of appliances. Next slide. And so subversively, we made these cartoons, but also we forced Energy Star to change the way they certify dishwashers. We pushed manufacturers to change the way they compare air movement in range hoods. We created a new testing scenario that people could test their burners at home. It was licensed by Bosch so that they could compare induction versus natural gas versus electric appliances and see how well they perform and how efficient those burners are. All of this subversion, I guess, culminated, next slide, in my wife allowing me to test efficiency on an 11-year-old Kenmore refrigerator, turning an 11-year-old Kenmore refrigerator into the most efficient refrigerator, mass-produced refrigerator available per cubic foot, simply by adding 1 inch of Home Depot foam on the outside. Obviously, I was in the wrong business, and after this, I spent time turning homes into zero energy homes, but turned into products, which is where I've spent most of my career, and connected with Dan Sexton, my partner and co-founder, and we formed Vata Verks. And to combine the two things that I've learned all over my time in appliances and my time in zero energy home building, there was a need for data, and there was a need for the kinds of data that appliances could do. For example, I was in cooking, but dishwasher hoses, $3 dishwasher hoses would fail and cause millions of dollars of damage in the kinds of homes we were going in. And it seemed like there needed to be a solution. So our first focus was residential, but we quickly pivoted to commercial. Here's the problem. In the commercial building sector, which commercial property owners and property managers are making rational decisions, they're looking for ways to find out what's happening in their building, what are their tenants doing in their building, what damage is happening in my building while I'm away for the weekend. They were seeking, and currently there's wide-scale deployment of technology in occupancy, electricity, HVAC, boiler, temperature, humidity. Where they were having problems were in the plumbed utilities. Primarily, our focus was water, but also gas. Both the plumbed utilities require third-party skilled installers to get sensoring. Loss of scheduling control because it required multiple visits by utilities or plumbers. It required coordination by the property manager. There was disruption to the building whenever whenever sensors were installed in line, which requires a cut of the gas pipe, a cut of the water pipe. They were extremely expensive, and the data quality and data control was fairly poor because these very often is data that the utility is getting, and although the utility data is correct, it is not high resolution. It is not. It is not finely granular. They're looking to make sure you pay for the gas and water you get. They're not looking to find out where tablespoons of water are going. Next slide. And so the problems that building owners and property managers are trying to solve are identifying leaks and catastrophe. That picture, by the way, is from Detroit. It is my favorite picture in the world. Nothing like it exists in the commercial side, unfortunately, but in the residential side, that is a keeper. Also on the right top slide is anomalies. You're looking at what a bill looks like, and that's a single data point per month. Building owners don't know when that anomaly took place, why it took place, which day, what time. That's a single data point. Building owners are also looking for tenant oversight, tenant usage. Oftentimes, plumbed utilities, not all the time, but oftentimes plumbed utilities are included in the rent, meaning the landlord pays the bill, and there's no real way to control costs or to identify who are the bad actors amongst the 30 or 40 tenants in your building. And of course, there are all several secondary benefits. LEED has a requirement for ongoing data. They require daily data recording for cooling towers. Demand response is coming up, which is fairly popular in electricity, but is also becoming more important for some utilities in natural gas. And certainly there are building managers that own or manage hundreds, if not thousands of buildings, and managing all of that diverse fleet of buildings becomes difficult. We make all that possible. Next slide. And so the solution that we have identified is not cutting the pipes, not bringing in a plumber, but simply using a 3-axis magnetic field sensor that is strapped to the side of your water meter. And what you have there at the bottom is a water meter, and outputting real-time, high-res water and gas data. Now, I just wanted to show one thing on this picture, because this picture is a little bit, it's not so much in error, but it tells you the wrong thing. That black cord that you see wrapped around the register is not our cord. That is the utility pulse output, and instead of cutting it, they just wrap the excess around the register. Our sensor is just slipped underneath there and strapped to the register and recording magnetic field fluctuations. Next slide, please. So we've solved the data problem in the earlier slide. We're solving the installation problem in this slide. Our hardware is sold to energy services companies that provide services to commercial building owners. These companies install electricity, temperature, humidity, all of those sensors that we mentioned before. With water and gas requiring third party, we get rid of the third party. Now water and natural gas sensors can be installed at the same time by the same sensors in a dry application, no cutting pipes, no bringing in third parties, all on the same day as all the other sensors. And it's a huge scheduling improvement, and it's a huge projects management improvement in how these buildings get up to speed, and how water and natural gas gets onboarded into control and onto the dashboard that these companies provide. Next slide. And so we're solving the analytics problem. Now, I want to be certain that everybody understands Vata Verks is a data company. We don't currently solve any analytics problems ourselves. We produce data. We sell to companies that have their own analytics and have their own backends and customer bases. But we allow them to apply their own analytics in a way that solves disaggregation or synchronization of water and gas data with all of the other data that's coming in, like occupancy and elevator occupancy and heating and hot water and electricity usage. We help solve the leak and anomaly detection problem, the efficiency program problem, and how you do baseline studies. Currently, baseline studies for new heating systems can cost, and this is quoted to me as $4,000 to $5,000. It's an invasive installation, no longer necessary. Able to track cost and usage, and for the cases where there's synchronization, a demand response, you now have a demand response possible. Okay, next page. And this is how the technology works. Inside water meters, in that brass, if you're looking at the picture, there's a brass chamber. Water passes through that brass chamber. It is a completely sealed chamber. The register on top, which is what the meter reader reads, where the numbers turn, that's just kind of held in place with a screw, but there is no transmission line. It's sealed. They're sealed from each other. The way information of flow transmits from the chamber to the register is through the use of a magnet in the chamber that spins when water flows. And so the register is a slave to that magnet. Magnet stops, register stops. Magnet turns, register advances. And this is technology that's been going on, I'm told, for over 100 years. Thank you, Wikipedia. But what it does is that magnet turns, it creates a fluctuating magnetic field that spills out into the basement, and we detect those and glean. We're able to glean rotations of that of that magnet inside the chamber and turn that into high resolution flow information that we transmit to our customers. Now, before we change here, you'll take a look at those sine waves at the bottom. And there's an arrow there from the peak of a red to another peak of a red. It doesn't really matter which sine wave you're looking at. This is real data, by the way, raw data. And so from peak to peak is a full rotation of that magnet. And of course, a rotation for 1 meter is different from another. That's called a K factor. How much water or gas flows with a single rotation. Now, this is fairly high resolution. So for a residential, for a family meter, a residential water meter, that could be one rotation is about 1/100th to 1/60th of a gallon. It's pretty good resolution. Now, some customers wanted even better than that, and so we were able to create something called a new technology. It's an option, which is ultra high resolution, which allows us to turn each revolution of the meter into 1/100th, 1/100th of that. That's our resolution. I get tripped up over those two words a lot, sorry. So we're able to differentiate 1/10,000th of a gallon for some residential meters. And the reason anybody would need that, most commercial customers don't, but the reason anybody might need that is for research into disaggregation. You're looking for edge effects, fine tracking of tiny leaks when you have and also when you have a very large meter, when the amount of water that goes through the meter or gas is enormous with a single revolution, you might be looking for extra resolution to be able to detect fine movement. Next slide. Value proposition is simple. It's both in installation and performance. On the installation side, it's simply low cost. We have less hardware, we have less labor. It's non-disruptive because we're not cutting the pipes, so it doesn't have to be installed after hours. It doesn't have any impact on the building's operation. It doesn't have any impact on tenants or your schedule. It doesn't involve the utility, so there's no requirement that you schedule a utility technician, which usually requires the property manager to get involved in coordinating. And usually a utility installation requires 2 visits plus a 3rd visit by my customer to hook up the utility's data output. So 3 visits become 1. It's meter compatible. It's incompatible with greater than 95% of gas and water meters, both residential and commercial. It's because we just do data and don't do analytics currently, it's agnostic to what the end users do with it. Our customers are oftentimes competitors with each other. They can compete with each other because they have their own proprietary analytics that they apply to our data. It's data compatible. We output an MQTT, Modbus TCP, Modbus RTU. We also have self-derived pulse, and the unit has an onboard data logger for those who require it. And of course, I think it's the data resolution and granularity is one of our strongest points. It's in that it is many orders of magnitude higher resolution and more granular than the utility data. It's up to 1 second data rate. By the way, customers never use 1 second data rate. It's a 1 second. Most customers use 15 minutes, 5 minutes, 1 minute. We use 1 second for demonstration purposes because it makes pretty pictures like this, but most customers do not use it that way. We have one customer, a university in the Boston-Cambridge area, that is using it on the 5-second interval, which I don't imagine they'll do that for very long because that's a lot of data. Next page. Our gas meter compatibility is, I'll just go through them, a rotary gas meter, which is the top left. Also, the top right is a rotary gas meter. That's the very first test installation of our remote sensor cable. Unfortunately, it's a little bit of a mess, but this is a customer installation at a Boston public housing project. Bottom left is a customer installation of a turbine gas meter in New York City. And let's see, bottom right is an installation on a diaphragm gas meter in my own home. Easiest to get photos of my own home. Next page. Our water meter compatibility, our bottom left, that's a displacement meter and a commercial size displacement meter in a pulse output configuration. You'll see the Vata Verks devices attached to the wall, and on the right of that is a pulse counter. Top right is that is a multi-jet meter from a customer. Multi-jet meters are not usually utility meters. These are not usually used by any utility company that I am aware of in North America. Most multi-jet meters I'm aware of are European made or Chinese, and they're Turkish also. They're brought in as by companies that are looking to get sub-metering. I think they might be less expensive. Nonetheless, if a multi-jet meter is there, or even a single jet meter is there, we're compatible. The bottom, the picture in the background, you'll notice a compound meter. There are 2 registers. Also notice the brown coils of cable. Again, I just want to make sure everybody knows those brown coils are not ours. Those are the utilities. Compound meter are for large scale uses of water. A compound meter has a small, kind of a residential size meter inside that is turning all times. But for massive peak flow, they also have a integrated turbine meter, which comes on only when demand requires. To capture both sets of data, you need 2 units, and they're enormous. This is a customer installation at a multi-hundred unit apartment building in Boston. You'll also notice another unit in that same picture on the top left. That is an irrigation, separate irrigation meter. Oftentimes irrigation is separate from fresh domestic water because irrigation does not go back through the sewer system. So you are hoping to get a discount on your water bill because you're using the water one way. You're dropping it on the lawn and not dropping it through the to have the water cleaned. This particular installation, that irrigation system was leaking continuously. They were hoping to use our technology to find out what the cause of that was. Next page. And this is our product line. We started off with the product line on the left, which is a VV100, kind of a Swiss Army knife of everything with MQTT and Modbus and Pulse and data loggers and just about the whole kit and caboodle. The VVK020, don't worry about that. It's the ultra high resolution. It's a firmware upgrade. It's the same product. Then if you notice from that probe right there on the ribbon cable in that picture is a very short ribbon cable. That's 18 inches. And lots of calls from our customers for much, much longer. So we launched a remote sensor probe that is 1 meter, but that is capable to go up to 200 feet. And so some customers thought 1 meter is too short, so we're offering significantly longer ones. But in any case, immersion, waterproof, that new sensor. And it also became the basis of the product on the right, the VV102, which is the kind of a low cost, very focused product that does Modbus RTU and also does Pulse shortly, I think. Next page. Our markets are primarily building efficiency, baseline studies and measurement and verification, which also includes usage and cost tracking. We don't know if customers have used it for lead, but it is useful for lead, but a lot of customers use it as a feeder of data for BMS, building management systems, and also to satisfy the requirements of various city and regional regulations around the country. It's being used for anomaly and leak detection and occupancy and oversight. As for gas demand response, those projects haven't started, but they've been approved for that, and we expect those projects to start shortly. There is ongoing research today for gas disaggregation, but beyond that, the sky's the limit should be its own heading. We make a hammer. We don't know how people swing the hammer. We're just trying to solve a particular problem of getting clean and efficient, non-disruptive data available for however our users can imagine it being used. We're agnostic to the end use, but these are the markets that we are aware of today. Next page. It's a small team. There are more people here actually that we that we have in interns, we have advisors and market advisors. I think the most important thing to talk about is Dan Sexton, who's not in this meeting. He's my co-founder. 37 years at General Electric's research and development, and we're talking about Swiss Army knives. Dan's a Swiss Army knife, and this product, our solution, the fact that we were able to come to this market and make a product that did everything that we hoped and dreamed, even when even when it looked darkest, it's up to him. It's thanks to Dan, and he's been just incredible in getting this company and getting this product working. Next page. And then what I'd like to do is do a demonstration, and as I understand, the ease to do it on the webinar is to do a video demonstration. So before we do the video demonstration, what I would like to say is that I normally do live demos with hardware, rotary diaphragm water meters that are on my desk. And for any of you who require live demos or further discussions, please contact me via this email address, and I would be happy to get into more detail on anything that follows. Now, the video that we're about to show you is a little bit of a training video, so it's 5 minutes, that's all, and it'll get into a little bit of the nuts and bolts on installation, tracking, and calibrating the meter. And then there'll be a much shorter video after, and then I'll take questions. Can we go to the video, please? Is it not coming up?
No, it isn't.
This is a YouTube video, so I can, hold on a second. Let me get it for you. Let's see here. Is there a way for me to share the screen and the audio?
Yeah, there should be. If you look at your options on the GoToWebinar control panel.
Okay. Share my webcam. I don't see it.
Okay.
All
would you
right,
be able to email us the link to the YouTube video?
Yeah. Why don't we take questions for a minute while I go get the video link.
Yeah, we might be able to give you control too. Let me see if we can pass it to you directly.
It's okay. I can. Let's see here.
There we go.
Okay. All right. Let's do that. Show my screen. All right. We're going to see if the audio comes through too. Tell me if it does. Can you hear that? Wait.
No, there's no audio coming through.
There's no audio. So let's go to questions while I get the. Let's stop sharing screen for a second. How do we do that? Can you take the screen sharing back?
Potentially, yeah.
Yep, I just tried to pass it back.
Okay, so I'll give you the link in a second here, and it is, alrighty. All right, where do I put the chat here? I just sent you a chat message.
Yep. Okay. 'Cause, yeah, I don't know. Maybe.
Okay.
Yep. 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 Yep.
Is it advancing? All right, it looks like the audio is not coming through. So what I will do is I will go through the audio live. So what we're showing here is how the unit is attached to the meter. And I'm showing a live screen on the left. That was my screen at the time. So we're opening up TerraTerm, which is the terminal emulator that allows, it's a freeware, and that's how you control our device. We make sure it is controlled correctly and configured correctly. Now I'm going to enter the username and password. The username and password are admin and admin. Secret, don't tell anybody. And then we will start to run water. So we're going to enter the tracking menu. So capital T. Yeah, this is quite, the transmission is quite slow, it's quite broken. And so we'll enter the tracking menu, and then we'll test out amplitude, which is the signal strength. The unit. So the sensor is right now on the meter, and we're going to run some water to check signal strength. You don't always know where the strongest location is, but in this case we did. You notice the 672, the 704, 660, those numbers just further up. That shows a very strong output caused by the fluctuating magnetic field. I used X to stop the function and R to reset to now I want to start tracking. So now I'm running water, and I quickly, within a few seconds, calibrated the sensor on the meter. Calibration is automatic. There's nothing required by you other than to make sure that the meter starts turning. The unit is looking for fluctuating magnetic fields, and as soon as it finds it, it counts. And right here, you'll notice 3 revolutions. So 3 revolutions is tied to that particular meter. It doesn't tell you how much water went through. And so what we need to do is figure out the K factor. The K factor can be known in advance. Maybe Vata Verks has already tested the device and already has what that K factor is. Or the K factor can be figured out in the field. And it's a fairly short putt to figure out the K factor in the field. You take a reading from the Vata Verks output, in this case, potentially 3, although my video is not advancing, so I'm still at 3. You take a reading simultaneously of revolutions, and you take a reading at the same time of what the register on the meter says. Then you have a bunch of water flow through, and you take the reading again. Is the video moving? Are we still connected? I'm not sure that we're still connected.
I don't see the video moving anymore now.
Yeah. I will just do it without the video then. So there are 3 ways of calibrating what the meter size are, figuring out the K factor. One, the easiest way, and some of our customers taught us about this, was simply to use the utility bill. So install the device, start returning data back to your operations, and using the first day and last day of your meter, your utility bill, to figure out how much water or natural gas passed through the meter, and dividing its revolutions that Vata Verks has counted, let's say 25,000 revolutions or 2 million revolutions in that month, divided by the total amount of water or total amount of gas that went through. There's a little bit of error involved there because you don't know the time that the utility started billing at the beginning or finished at the end. But some customers, when they're out looking for that detail, do that. Second, the easiest way, at least for water, is using a measured container. So the Vata Verks device is counting revolutions, and you use a half gallon, a measured half gallon, a measured gallon, a measured 5 gallons, the more the better, and you take the total number of revolutions that my device, the Vata Verks device, is counted and divided by that measured volume, and that'll give you the K factor. The only trouble there is it can't be an enormous building. You have to have total control of the building. It's pretty good for single family, small commercial, not so good for the John Hancock building. You would have to have complete control. And then the most common is just use calibrating to the meter itself. Simply taking a simultaneous reading at the start of your revolutions. In that case, the last one we saw 3, and a simultaneous reading of the meter, take a picture of the meter, and having a bunch of flow go through the meter, either by the tenants or just go off and have a cup of coffee for 10 minutes, come back, take another simultaneous reading of the revolutions and of the meter. You subtract, get the delta revolutions divided by the delta volume from the register, and you get a very, very highly accurate, the most highly accurate K factor. And this information can be transmitted via pulse or MQTT, can be used as or Modbus TCP or Modbus RTU, and it is transmitted via router or our customer's gateway to their back end, and all sorts of fantastic services are provided. The other video that you didn't see, and that for people who are interested, that was the ultra high res. If you remember the data that showed where it said 3.00 revolutions, 3.00 revolutions, ultra high res, that option turns that 0.00 into an actual number. It populates the 2 digits to the right of the decimal point by using a fine tracking and a separate algorithm that can identify what fraction of the revolution you've gone to. So for a residential water meter, and I only use it because it's kind of a standard, that would be a resolution of a fraction of a gram of water. And on your residential diaphragm gas meter, that would be a resolution of about 1 BTU. Yes, massively overkill for most commercial customers, but for research and development, university applications, very helpful, very, very necessary. I'm ready to take questions from anybody who's ready to ask them.
Great, yeah. So just to kind of kick the questions off, we saw that you had New Ecology's logo on this slide currently.
Yes.
Could you please talk more about your relationship with them and if you've used this technology in any low-income projects?
In fact, New Ecology has been our anchor customer, our first customer, and they were interested in our product before there was a product, and they have been extremely patient with the first launch and through the various hundreds of firmware iterations to the stable product that we have now. So yes, they I can't say exactly. I will leave how they end up using the device is really, I think, maybe confidential to them, but they have been interested in both the water and gas aspect, and these units are deployed in, I don't know if public housing is the right term, because certainly these places look a lot better than I imagined these, but I think they're mixed income that I've seen, and I think they're kind of public-private partnerships. But yes, the kinds of buildings that New Ecology does deploy in.
Got it, thank you. Another question we received is whether you've considered going into data analysis, and if you haven't so far, why not?
I can. Up till now, we haven't, because we're in a tiny boat with a very few people, and we had to chuck a lot of important things over the side to get to first revenue. So anything that was after, anything that was more involved in the data, including the back end and the front end, we created things that were rudimentary for for customer evaluation and for demonstration purposes, but we decided to hold off on getting deeply into analytics until now. Our advisor from Brandeis had strongly recommended that we move forward with that, and so coincidentally, we are now working on a university project with master's students who are developing and looking at how our data can be leveraged into analytics. But up till now, we've only been selling to customers who have their own analytics and wouldn't be using our analytics in any case. It is restrictive, though, to focus only on companies that have data scientists is a little bit restrictive.
Got it. Thank you. I think those are all the questions we have right now. But thank you for leaving your contact info. I'm sure people will reach out if they have any further questions. And thank you so much for presenting today. It was very interesting and we really appreciate it.
I would just like to say one thing, and I apologize that we had a video snafu, which is it's kind of fun. I think I'm wondering if what we could do for anybody who's interested. I'm happy to do another demo. We could schedule a demo with anybody who's interested where I can share the screen and show a live demonstration showing data coming out as well as the sensors going on, moving the sensors around on the meters, and outputting both tracking and doing any part of the demonstration you like. It's all very easy. I have an adorable little air blower here that helps me keep them, it's because one of the things you learn when you're in business that works with water and works with meters is you never want to test with the actual substance. You don't want to test with natural gas, and you certainly don't want to test with water. So we use air blowers for everything. But listen, I appreciate everybody's time, and I want to thank again MassCEC for putting this on and inviting me to tell you all a little bit about Vata Verks. Thank you very much.
Yeah, thank you. And then for the rest of the attendees on the line, we will have another presentation starting at noon. So in the meantime, just leave it here. And as a reminder, we'll have more CleanTech Spotlight webinars coming up in the coming couple weeks. So stay tuned for the presentation at noon, and feel free to take a break and get food or whatever. Thank you again.
Thank you.
All right, so it's about noon. Gabby, do you want to kick it off with a brief introduction?
Yeah, sounds great. So welcome everyone, or welcome back if you joined us for the last webinar series. So this presentation is a Catalyst grantee. Professor Wang will present on his solar energy research at Boston College. Professor Wang and his team recognize it is not possible to rely solely on renewable energy as the main electricity supply. So because of this, they're developing new technologies that can harvest and store solar energy on a large scale. Thank you again for joining us, and please enjoy the presentation. And just as a reminder, any questions that you have, feel free to use the question submission feature and type them in as the presentation is happening. And at the end, there will be roughly 15 minutes reserved to go over those questions from the audience. Thank you so much.
All right, Dr. Wang is currently gathering some materials for the presentation. He'll kick this off in a couple minutes. Please stay tuned.
Hello, can you guys hear me now?
Yep.
Yeah, my apologies for the technical difficulty. I seem to have some difficulty with my computer microphone. My apologies. So I'll start over again. So thank you very much for this opportunity. We really appreciate Massachusetts Clean Energy Center to organize this webinar series. And the project I'm going to present is part of the companion fund provided to go with this National Science Foundation Chemical Engineering Division grant geared toward engineering transport through directed orientation of transition metal chalcogenide catalyst. I'll explain what this catalyst is and what it does in a second. And this grant has been able to allow us to train additional workforces as graduate students for clean energy through mostly solar hydrogen generation project. Currently, we are in year 3 of this project, and it's a team of 3 principal investigators, me as the lead in Boston College, and working with Professor Pratap Wall and Aaron Deskins at the Worcester Polytech Institute. If you may advance to the next slide, please. So just try to provide you some context of the abundance of solar energy. A couple years ago, National Renewable Energy Lab in Colorado did a survey, and this provides technically available solar energy resources in the United States. And this gives us a number that really doesn't make a whole lot of sense to me until I compare, if you can go to the next, until I compare with the electricity generation. And depending on where you look at this, electricity generation in the United States represents about 1/3 of our total energy consumption. As you can clearly see, we have more than enough solar energy to meet our energy needs, not only for electricity, but for other sectors as well. So that's kind of the first quantitative information I wanted to share. If we go to the next slide. So another way to look at this is actually to look at the cost of solar electricity. So this is a very detailed information. U.S. Energy Administration publishes this updated data every year. So if you can actually advance the next animation. This is very detailed information. What I want to draw your attention to is the far right column. This is a levelized cost of electricity that includes all tax credits. And I just wanted to make a comparison between geothermal and solar photovoltaic. And geothermal is almost known as sort of the golden standard of low-cost electricity. As you can clearly see that right now, solar photovoltaic, the levelized cost, is almost comparable to the lowest cost of geothermal. This is very interesting to me. So, I have 2 pieces of information. The first piece from the previous slide is that we have more than enough solar energy to meet our needs. And then on this slide, this is a very detailed calculation based on pretty well-balanced models. The solar electricity can be also dirt cheap. So you have something that's abundant and very cheap. It really raises a question why we are not using it. Also on this slide, you'll notice that solar photovoltaic is in the non-dispatchable technologies. So why? What does that mean? If we can go to the next slide. So if we start to look at the variations, the seasonal variations of solar electricity, it starts to tell us some story. So right now, the solar electricity accounts for less than 2% of the total electricity utilization. We'll notice that, from this curve, that solar electricity didn't become a thing until fairly recently, less than 10 years ago. But what we'll notice most apparently here is the seasonal variation. The solar electricity will vary by up to 50%, actually a little bit more than 50%, depending on which season you are. This raises a critical concern. The concern is that if we wanted to rely on this cheap and abundant energy source, how do we levelize this supply? So what kind of storage media, what kind of storage solution can we have? Can we go to the next slide, please? So this is how we actually identify. We identified storage, energy storage, as a critical challenge. And we use solar electricity as an example to illustrate this point, but it's not limited to solar, and it's true for wind and other sources of renewable energy as well. So, and overall, this has been a motivation for our research program at Boston College in collaboration with our friends at WPI, we try to develop and advance technologies for large-scale energy storage solutions. If we go to the next slide. From a scientific perspective, there are a number of ways of storing energy. Of course, what we are most familiar with would be the batteries. So that's what you see in the middle of this table. Lithium-ion battery is probably the golden standard right now. And then if we use a unit, megajoules per kilogram, you will notice that it conveniently provides number one as a unit. And if you compare the different existing technologies, you will notice there is a clear line, dividing line between the current electrochemical energy storage and gasolines. Of course, you can argue lithium-ion battery is a mature technology. Why don't we use it? The answer to that is very simple. We just don't have enough of lithium to meet our demand. Even for a rich country like the United States, it can be a very nice demonstration. But when we wanted to use it at a grid scale, this creates a huge challenge. And then, from this table, we can also clearly see why, as a society, we are so addicted to gasoline, because the chemical bond just is a great way of storing energy. There is only one other way of storing energy at a higher energy density. That would be nuclear. We haven't figured out how to manage and control that yet. So chemical energy, that's the most important insight that guides our research. Chemical energy is really a great way to store energy. I'm talking about a large scale. Of course, for transportation, batteries still play a very important role, but I'm mostly thinking of to meet this gigawatts kind of grid scale society energy needs. If we can go to the next slide. So this is basically the basis for our study. We wanted to utilize solar energy, and we wanted to use chemical energy to store and levelize the supply of solar energy. And the dream would be that we use a catalyst. This catalyst can directly harvest light and use the harvested energy to turn out clean chemicals such as hydrogen. So optical energy in, chemical energy out. And it's not really a new dream, and the real challenge lies in materials. We don't yet have a material that can give us the desired performance. So if we make it, go to the next slide. So this is basically the milestones we have set for this project. Here, transition metal dichalcogenides basically refer to materials such as moly sulfide, and this is a very unique class of materials. They are much cheaper than other materials like platinum, this noble metal, but their performance has been shown to be on par, and that's what our goal was. This is a 3-year project. In the first year, our goal was to synthesize, finding ways to prepare the materials, and the year 2 is mostly trying to understand some of the detailed morphology of the catalyst, whether they stand up or lying down, how it's going to basically impact the performance as well as the cost. And lastly, in the last year, which we are working on right now, a little bit delayed by the current pandemic, but we are making good progress, is trying to look at from a system level and to see what kind of optimization we can do. And our goal, the targeted reaction, is hydrogen generation, solar hydrogen generation. If we may go to the next slide, please. So just to give you some recent progress in this, as you can see, one of our goals, this is going to some details here, as this catalyst, this is a transition metal dichalcogenide TM. See here, the very unique feature of this material using moly sulfide as one example. A very unique feature here that it's a 2-dimensional material, and it has been showing that at the edge, this is where they're most active as a catalyst to produce hydrogen. On the basal plane, essentially on the planar side, they are less active. So naturally, we would want to make them stand up. But as you can see, if you try to throw a coin, the chance for them to stand up is very difficult. That's precisely what we have identified as an opportunity for us. So we have learned over the years how to make them to lie down and to stand up. Our goal is to make them stand up on the right-hand side. And then, of course, for this recent progress, we try to make this. Previously, we learned how to do it. Most recently, we try to make them on low-cost substrate. This is to reduce the overall cost of the material. Can we go to the next slide? So just to show you some examples, this is a scanning electron micrograph, and we learned the trick really lies in the detailed conditions. So we use chemical vapor deposition method, and then we can actually by controlling the combination of temperature, flow rate, and all these details, we can control to get them either on the left-hand side totally flat, or on the right-hand side, they actually can grow up, and the schematics are showing on the right-hand side. I just wanted to emphasize that this is a project that involves computational chemists. Aaron Deskins is an expert in computational chemistry. So the schematics that's shown on the right-hand side is not just hand-joined. They're actually generated a low-energy state as simulated by DFT. Can we go to the next slide? So to provide some comparison, what we have been trying over the past year has been trying to study how we can make the same kind of catalyst on carbon foil. As you'll see, previously, mostly the success of vertical catalysts were achieved on gold foil, and the cost of them, the benefit of carbon foil is very apparent, very obvious, and the performance is slightly worse than gold, not by a large margin. So essentially, we can actually reduce the cost by 60%, but maintain the performance at 90%. So this is to us, this is a pretty good kind of trade-off. So we're pretty happy with this result. And I just wanted to mention that previously on current state of the art, the best catalyst that can deliver the kind of performance would be platinum. So we're really competing with a very precious material. So this catalyst has a really good prospect to be used in practical devices in the future. Can we go to the next slide, please? And of course, this is a research project. It's the application of this still has to be developed. But we just wanted to show that this kind of study, the most important impact we're making is to train the students, and when they graduate, they're going to get ready. So we just wanted to show, for instance, in this slide, that the type of knowledge we generate can be readily transferred to creating other materials. For instance, this is another transition metal dye chalcogenide, tin sulfide. It works really well as well. And then, we have also published these results in a series of papers, peer-reviewed journal papers. Can we go to the next slide? So this is the training. The set of students are still with us. So on the left-hand side, this is the team at WPI involving two principal investigators. To the far left, that's Aaron Deskins, and the third from the right, that would be Pratap Rao, and the rest are students, graduate and undergraduate students. And on the right-hand side is our team. It trains one graduate student on our side, 3 graduate students on WPI, as well as various undergraduate students. So I think this will actually conclude my presentation. I just wanted to mention that, again, this is more of a research project, maybe different from some of the other presentations of teams you have seen. But hopefully this offers you a flavor about the promises and challenges associated with solar energy, and some of the solutions that's been developed in university labs that with great promises in meeting this challenge. I apologize again for the technical difficulty in the beginning, but I'm very happy to take any questions you may have about this project.
Yeah, thank you. A reminder to all the attendees to please submit your questions in the question box, and then we can ask them on your behalf. To kick it off, I was wondering, I know you mentioned that this research is still fairly early stage, but I'm wondering what next steps look like for your team and the team at WPI, and looking kind of super long term, what any path to deploying this technology in the field would look like.
So, and it will be a little bit difficult to kind of be specific here about what we envision, that there are at least 2 different ways of deploying this technology. One is to readily just basically take the catalyst and then substitute in existing electrolyzers, the kind of alkaline electrolyzers where platinum is used, and then by substituting platinum with this transition metal chalcogenide, we will be able to reduce the cost significantly. And this is one way. Another way here is that this is what we are working on more kind of even longer term, is a direct solar to electricity. For the electrolyzer, you will still have to couple it with a photovoltaic. The advantage is that both technologies are already pretty mature, so this is more of a material substitution. But for the second approach, which is what we as university research labs are more kind of interested in developing. It's kind of just to change the paradigm, and then to cut the the wires between the solar cells and the electrolyzers to make a direct photoelectrochemical cell, so light in, chemical out. There have been techno-economic analysis that shows that this approach could break the barrier. Right now, our target is very simple. We wanted to meet the DOE's target of $2 per gallon equivalent for hydrogen. And the various models have shown that using a solar cell plus electrolyzer, it would be very difficult to reach that goal. And it's possible to meet that goal with a simplified configuration. But there are a lot of moving parts, so we're very interested in seeing whether this goal can be realized.
Yeah, great, thank you. I think another question we have is how the current COVID-19 pandemic is affecting your work. Do you foresee any long-term delays in the project, or just how has it affected your work?
Yeah, so I think we are affected the same way everybody else is. So for instance, in our university, the lab was closed to kind of follow this social distancing about a month and a half ago now. So in early March, university lab is closed. Students are basically staying at home. They're still doing research by literature study, but as an experimental group, we can't really kind of implement any ideas. So how much this will set us back is hard to predict, but we're not alone, and the situation is not unique to us. And right now, I think in the middle of this, it's really hard to predict, and I tried very hard to stay connected with my team, and we're talking about new ideas and how to implement them. And we just kind of hope for the best. Hopefully the situation will improve soon, and then we'll be able to move forward. I think we're like anybody else, sort of in the game here, praying for the best, hope for the best.
Got it, yeah. I'll give it another minute in case anyone has any other questions they'd like to submit. All right, I think that then is all the questions we have today. I'd like to thank you for presenting virtually. This is super interesting, and it's always great for us to learn more about the specific milestones achieved under these projects. So thank you again for the great presentation, and thank you everyone for attending. Have a great Friday, everyone.
Thank you very much. Have a great weekend, guys.